In this video, I want to look at taking the inverse transform a little more. Let's look at the inverse transform of 2 over s cubed. So let's go to a table. We're looking for the inverse transform of 2 over s cubed. So I'm going to be looking in this second and fourth column for something that might look like that. And if we scroll down, we actually get it right here, where n is equal to 2. That would give me a 2 on the numerator and an s cubed on the denominator. So we would have t squared. That tells us that the inverse transform of 2 over s cubed is t squared. The next one I want to do is the inverse transform of 3 over s squared plus 9. And first I'm going to rewrite this as 3 over s squared plus 3 squared. So let's go to our table and see if we can find something of this form. Here's our table. I want something of the form 3 over s squared plus 3 squared, and we can see that that happens right here, where b would be equal to 3. I would have a 3 over s squared plus 3 squared, which is exactly what I had. So my solution would be sine of 3t. So this inverse transform of 3 over sine squared plus 9, sine of 3t. Now let's try to find the inverse transform of s minus 1 over s squared minus 2s plus 5. And this one's going to be a little bit harder. You can look on your table, but there's nothing of this form on the denominator. So instead we're going to rewrite it. Denominators on the table tend to look like things. So we're going to rewrite s squared minus 2s plus 5 to something that looks a little more like what is written on our table. And our table tends to write things in the form s minus a squared plus b squared. So this is what we're going to try to write it as. We can expand out this right-hand side. We would have s squared minus 2as plus a squared plus b squared. If I look at my s terms, we have that 2, or negative 2, is equal to minus 2a. So that tells me that a is 1. And if I look at my constants, we have that 5 is equal to a squared plus b squared. We already know that a is 1. So that tells me that b squared is equal to 4. From there, we get that b is 2. So I'm going to rewrite this transform as the inverse transform of s minus 1 over s minus 1 squared plus 2 squared. And so let's see if we can find something like this on our table. Here's our table, and we have something of the form with an s minus 1 on the top, and the bottom is an s minus 1 squared plus 2 squared. So it's of this form right here, where a is 1 and b is 2. So we have e to the 1t cosine 2t. That tells me that this inverse transform is e to the t cosine 2t.